This is the world's fastest tractor. It's called the JCB Fastrac Two, and it recently averaged 135.19 miles an hour with a peak speed of more than 150 miles an hour as it set a new world speed record for modified tractors. It's the subject of the 2019 Autocar Christmas Road Test, and I'm going to give you a full technical overview, the likes of which you will not see anywhere else, and then we're going to go for a drive. This, the world's fastest tractor, is based on this similar JCB Fastrac. So let's start by having a look at the engine, because without that, if I just lift up this engine cover, which is out of the standard mould but aluminium to make it lighter, and nestled in behind all of these ancillaries is a JCB 672 diesel engine. That means it has 6 cylinders and a capacity of 7.2 litres. Now its block, head and crankshafts are all the same as a standard JCB. The pistons are standard but machined down to give a lower compression ratio, and there is a huge turbo whose best work is done above 2,500 RPM. Now typically a tractor may operate at around 1,500 RPM, but here there is a 3,400 RPM red line. Peak power is 1,016 horsepower, peak torque is 1,340 foot-pounds, but one result of that vast turbo is that there is quite a lot of turbo lag. So there's 4 intakes here. This is the main engine air intake, but you see one to this side as well, which is for an electrically driven supercharger, which tries to keep the turbo spinning at low revolutions. There's 2 down here as well. This is for an oil cooler. This is for a torsional damper on the engine. Now it still has a 4 valve per cylinder head. The exhaust valves are a different material because the combustion temperatures are so much hotter than standard. And that comes out into an exhaust, a 3D printed Inconel exhaust, which gets to pretty much 1,000 degrees centigrade. So there's loads of heat everywhere. So how do you mitigate some of that heat? Well, you load up these pods at the front with 25 kilos of ice for each run that you want to make. And that passes through, the water from that passes through this massive water to air intercooler, which can take air that's coming from the turbocharger, comes through the turbocharger, might be 280 degrees or more when it's coming into this intercooler. By the time it goes out, it's at 10 degrees centigrade. And then there's some more water injection onto the inlet rail as well. So it just lets loads of air in, loads of fuel in. The bigger the bang, and the more power it makes. Now let's stick with the engine and transmission. It drives through a Truck ZF 6-speed manual transmission, which is unusual. Tractors usually use a CVT, and it's got a foot-operated clutch. Now that's using a JCB clutch that they developed in the late 80s, early 90s. It's an 8-plate, multi-plate clutch with all in a wet oil bath, and the idea is you slip it. Now for somebody like me who comes from cars, and if you're driving rare, valuable, weird cars, owners quite often say, look, the clutches on these are really expensive, you know, just please don't break them, they don't last very long. You're better off stalling than slipping the clutch because we don't want to wear the clutch out. Pretty much the opposite is true here. For reasons I'll come to in a minute, you don't really want to stall this. So what you want to do is slip the clutch massively. When JCB is testing these clutches, it fits them to a tractor, they pull 20 tons, they go at full speed, and then they just put it in reverse, and they let the clutch do all of the slip. It's a sort of an abuse test, but this is how strong those clutches have to be. So it's designed to have loads of revs put on and the clutch slipped all the time while this thing accelerates. Now, this Fastrac is rear wheel drive. Most Fastracs are 4-wheel drive, but this doesn't have to go off-road, it doesn't have to pull anything, it just has to go in a completely straight line. So the geometry is dead straight. It drives straight out through this 6-speed gearbox. 5th gear is a 1-to-1 ratio. Tractors usually have a reduction gear on each wheel. This doesn't get that. It just goes straight to a spool differential on the back. So the prop shaft is from another tractor, but is a standard prop shaft. The pinion and crown wheel are standard Fastrac pinion and crown wheel, and then the spool differential locks the rear diff, so both rear wheels travel at the same speed, which means you have to take a very broad turning circle when you go anywhere because the wheels don't shift at different speeds. Now these tyres come from a standard tyre mould, however they are made from a different compound to usual, and they've been tested to 160 miles an hour on an aircraft test rig. The tread depth is usually 27 to 30 millimetres, but here it has been buffed down to 10 millimetres, so it still looks a little bit tractory, and each tyre weighs 80 kilograms. Now, in the outside of the tyre, there are two steel bands to limit the expansion of the tyre at speed, and at 150 miles an hour, these tyres are only expanding by 2 millimeters. It's not only the wheels and tyres that are lower, the whole thing is lower. So a Fastrac is unusual in tractor terms in that it has a separate chassis, which makes it slightly more truck-like than tractors. A lot of tractors, for ruggedness, they just have an unsuspended rear end and then the suspension is all done in the cab. Well, Fastrac isn't like that. It has a chassis running through. So I think you go normal tractors, trucks, and Fastracs and Unimogs are sort of somewhere in the middle of the two, which is why this is a quick thing all round and quite good, because it had quite good on-road handling by tractor standards. So the chassis on this has been lightened for a start, but also there's a centre section which has been lowered. So overall, it sits 200mm lower, which is why you may note the front axle on this is V-shaped rather than straight across, because it just means that the engine and gearbox sit lower as well, so the axle has to sit beneath it. And then this cab has been lowered still, so the whole thing's 200mm lower, and then the cab is another 200mm lower, and the whole caboodle is 300mm narrower. The reason for that is because you want as small a frontal area as possible for as little drag as possible. So you will notice that sort of front bumper, which has a kind of splitter effect. It diverts some air underneath, it diverts some air around the bodywork. The drag coefficient is something like 0.48, which is not spectacular by, say, road car standards, but it's very good by tractor standards. Some of the air goes underneath and there is a little bit of lift, but this is still quite heavy. It's not a massive issue. It's kind of 50-50 balanced front and rear, so that's not a big deal either. So the world's fastest tractor weighs just under 5 tonnes, as opposed to a standard JCB Fastrac, which weighs in at 8.5 to 9 tonnes, depending on its equipment. So in addition to reducing the weight of the things that are on it, the other thing you can do to make it weigh less is not put some things on it at all. So you may note these 3 tanks. They are because there is no compressor on board, because compressors are heavy. There's also no huge battery on board. So, you know, I said you don't want to stall it. That's because if you want to start it again, somebody has to plug it into a big battery or a big generator, and that requires a van driving alongside it. So basically, don't stall it. This bottom tank here puts compressed air, it's a scuba dive tank, it puts compressed air into the turbocharger to keep it spinning between gear shifts, because you just want to keep that turbo spinning at all times. The 2 tanks above it are arguably even more crucial, because they are the compressed air canisters for the air braking system. And once they're empty, there are no brakes. Thankfully, they do about 40 stops. These guys tend to recharge them after about 20, and this is not a vehicle that does many stops anyway. But anyway, that is there because there is no compressor on board. The brakes, incidentally, are discs front and rear, twin caliper at the front, single caliper at the back, and they're the standard Fastrac brakes. Because although this has to stop from 150 miles an hour, it doesn't have to do it very often. And it only weighs just under 5 tonnes rather than 8.5 to 9 tonnes, and it's not towing anything else. So they are more than up to the job. There is, however, a parachute here, you may note, which is more for look than effect, I think. But anyway, let's go around and take a look inside. All right, so in here, it doesn't feel very tractorish at all. It almost feels like a kind of cartoonish and big version of a race car. There's a huge FIA roll cage, which is bolted directly to the chassis. I'm in this big FIA seat with harnesses, and then in front of me, although this is the standard Fastrac steering wheel, the steering lock has been reduced greatly because all I need to do is go in a straight line. It's about 3 turns between locks, and it's a hydraulic system, so there's actually not a direct mechanical link with the front wheels. It's a hydraulic link to the front wheels. Got 3 big fat normal JCB pedals, and then this huge 6-speed H-pattern manual gear shift, so it feels really focused, really business-like. I've got these emergency exit panels should I really need them. It's a really cool, functional feeling interior, on which note, it is probably time to go for a drive.
This tractor has been so close to its design limitations when it did its 150 mile an hour run. I detected a few hairline cracks and things in the diff, but they don't want to run it that fast. So instead of 1,000 horsepower, I have approximately 500-600, which is what this tractor did in sort of July this year when it went at just over 100 miles an hour. But I can see 71 degrees oil, 51 degrees gearbox temperature, and then WCAC, I can't remember what that is, at some water temperature, which is sitting at 15 degrees. Right, so I need to whack into revs, slip the clutch well, keep the revs up at 2000. Because if I stall it, they have to plug it in again, basically. Oh yeah, so just give it loads of revs. That's the way, just give it lots of throttle. And it's away. 3000 goes to reach to shift up. It's a big, long gear change. And then get back on the gas. So what they're also not using today, as well as all the power, this is fast, that's 70 miles an hour already, 71.2. This is quick, but it feels very stable, the steering is incredibly light. And you just sit high, it's very smooth, no wing noise, quite a lot of engine noise. A little bit of sort of resonance up here at about 100 miles an hour, that is 100 miles an hour, but in here, it's very quick. Right, I'll just lift off, go easy, just try these brakes out a bit. It's so stable, it's really cool. And it's not designed to come down through the gears, so basically ease off. Because of the small diff, use all of the runway.
Everything okay for you, Matt? Over.
Everything's fantastic. Happy days. We'll see you next time.
What I loved about Fastrac is not just how fast it goes, but how easily it does it. It's totally straight, totally immune to crosswinds. It is a real testament to the engineers who put it together, and it's a fantastic speed record machine. For more brilliant machines, join us throughout 2020. Thanks for watching Autocar in 2019, and we will be back in the new year with loads of new fantastic videos, including the return of Will It Drift and also a series of how-to videos. So Merry Christmas, Happy New Year, and we'll see you very, very soon.